In this lecture, I am going to present what is statically determinate and statically indeterminate structure, and how to determine the static indeterminacy of rigid jointed plane frame and rigid jointed space frame by using two approaches. Then I would like to explain some examples how to determine the static indeterminacy of rigid jointed plane frame by two approaches. First we have to know what is statically determinate and indeterminate structures. Statically determinate structures are those structures which can be analyzed with the help of equations of static equilibrium alone. And statically indeterminate structures are those structures which cannot be analyzed with the help of equations of static equilibrium alone. These type of structures are also known as hyperstatic structures. In the case of a statically indeterminate structures, the number of unknowns is greater than the number of independent equations derived from the condition of static equilibrium. So in this case, additional equations are required to get the number of unknown reaction components. The additional equations based on the compatibility of deformation must be written in order to obtain a sufficient number of equations for the determination of all the unknowns. The number of these additional equations necessary for the solution of the problem is known as the degree of static indeterminacy or the degree of redundancy of the structure. In this lecture, I am going to explain two different approaches which is used for the determination of degree of static indeterminacy of rigid jointed plane frame and rigid jointed space frame. Then coming to the first approach, in this approach the total degree of static indeterminacy is equal to the sum of degree of external and internal indeterminacy. That is the degree of static external indeterminacy. This is denoted by D and the subscript SC, and the degree of static internal indeterminacy, and this is also denoted by capital T and the subscript SI. Then the total degree of static indeterminacy can be determined by ds is equal to dsc plus dsi. First, coming to the rigid jointed frame, then how we will know the statically determinate and statically indeterminate internally. A rigid jointed frame is statically determinate internally if its members form an open configuration resembling the structure of a tree. This type of structure. So, open configuration means there are no loops or closed cells. So here you see, so this is like a tree shape, all the branches are open, this is like a tree shape, there is no closed cells or closed loops. So this type of structure is called the statically determinate internally. This is the rigid jointed frame, and this type of structure is statically determinate internally if the shape is like a tree shape. Look at this figure. Here all the boxes are closed. If a rigid jointed structure does not have open configuration, it is statically indeterminate internally. If the structure is closed loops or there is no open configuration, then the structure is called the statically indeterminate internally. This is the example of the statically indeterminate internally, because here all the loops are closed, there is no open space, so this is statically indeterminate internally. How you have to make this statically indeterminate internally to statically determinate internally? So that here A statically indeterminate structure may be converted into a statically determinate structure by making sufficient number of cuts so that the resulting configuration is open. These are the closed loops. So here you have to cut the structure such a manner that so the resulting configuration is open, there is no closed loops, and there is no split of the structure. This is one structure, all the branches should be open, there are no closed loops. So this type of structure is called the statically determinate structure. So in this structure, and if we will cut here, this become the open space, and we will cut here, this become the open, and if we will cut here, this become the open, if we will cut here, this become the open, and if we will cut here, this become the open. All the loops are opened, and there are no closed loops. So this is your statically determinate. This structure is converted to the statically determinate structure. This statically indeterminate structure is converted to the statically determinate structure by making 5 number of cuts, so that the structure become the open configuration. At each cut, 3 reaction components, 2 forces and 1 couple are released in the case of plane structure. In the case of plane structure, at each cut, so there are 3 reaction components, 2 forces and 1 couple are released, and in the case of space structure, 6 reaction components, that is 3 forces and 3 couples are released at each cut. So the degree of static internal indeterminacy for a rigid jointed plane frame can be determined using this equation, that is dSi is equal to 3 into C, where C is the number of cuts. Similarly, the degree of static internal indeterminacy for a rigid jointed space frame can be determined using this equation, that is dSi is equal to 6 into C, where C is the number of cuts. And in the case of space frame, at each cut, so there are released 6 reaction components, and in the case of rigid jointed plane frame, at each cut there are released 3 number of reaction components. Then coming to the external indeterminacy, how the degree of static external indeterminacy of rigid jointed plane frame and rigid jointed space frame can be determined. The external indeterminacy is related to the support system of the structure. If the number of independent reaction components is more than the available equation, the structure is externally indeterminate. So in this case, the degree of static external indeterminacy for plane frame or for the space frame can be determined using this equation. In the case of plane frame, the degree of static external indeterminacy can be determined using this relation, dSc is equal to r minus 3. Similarly, in the case of space frame, the degree of static external indeterminacy can be determined using this equation, that is dSc is equal to r minus 6, where r is the number of reaction components. Then after getting the dSi, the degree of static internal indeterminacy, and dSc, the degree of static external indeterminacy, then the total degree of static indeterminacy can be determined. So dSc is equal to dSc plus dSi. So this is the first approach. Then coming to the second approach, first we'll discuss how to determine the degree of static indeterminacy of a rigid jointed plane frame. Here you see, in the case of plane frame, in every member of a rigid jointed plane frame carries 3 unknown internal forces, that is axial force, shear force and bending moment. And the total number of reactions, you know, this is R, and this is the, at each member there are 3 internal forces. So what is the total number of unknown forces? The total number of unknown forces is equal to 3m plus r. 3m is the total number of internal forces and r is the total number of external forces, that is the external reaction. So the total number of unknown forces is equal to 3m plus r. Then the condition of static equilibrium provides 3 equations at each of the j joints. At each joint there are 3 static equilibrium equations provided. So if there are j number of joints, so at each joint there are 3 equations. What is the total number of independent equation? That is equal to 3 into j. So 3j is the total number of equations of the frame, rigid jointed plane frame. And this is the total number of unknown forces, 3m plus r. Then what is the degree of static indeterminacy? The degree of static indeterminacy for a rigid jointed plane frame can be determined by taking the total number of unknown forces minus the total number of independent equations. So the degree of static indeterminacy ds is equal to 3m plus r minus 3j. So this is 3m plus r is the total number of unknowns and 3j is the total number of independent equations. So this difference is called the degree of static indeterminacy of a rigid jointed plane frame. Then we will discuss how to determine the degree of static indeterminacy of a rigid jointed space frame. You know, in the rigid jointed space frame, each member carries 6 unknown internal forces, 3 forces and 3 couples. Total 6 forces carry each member of a rigid jointed space frame. And the total number of reaction components is equal to r. So what is the total number of unknown forces? The total number of unknown forces is equal to 6m plus r. 6m, this is the internal forces, and r, this is the external reaction component or external forces. So this total is the total number of unknowns. Then in the case of rigid jointed space frame, at each joint there are 6 conditions of static equilibrium equations. At each joint there are 6 equations available. So the total number of independent equation is equal to 6 into j. Then the degree of static indeterminacy can be determined by taking the total number of unknowns minus the total number of independent equations. That is the difference between the total number of unknowns and the total number of independent equations. That is 6m plus r minus 6j. So this difference is the degree of static indeterminacy of rigid jointed space frame. So using this equation, so you can determine the degree of static indeterminacy of a rigid jointed space frame by second approach. This is the summary. The degree of static indeterminacy of rigid jointed plane frame ds is equal to 3m plus r minus 3j, and the degree of static indeterminacy of rigid jointed space frame ds is equal to 6m plus r minus 6j. So using this equation you can find out the degree of static indeterminacy of frame, where m is the number of members and r is the number of reaction components and j is the number of joints. Then coming to the some example, how to determine the static indeterminacy of a rigid jointed plane frame. So for rigid jointed plane frame, this is the expression ds is equal to 3m plus r minus 3j by second approach, and by first approach you have to find out what is the internal degree of static indeterminacy and what is the degree of static external indeterminacy. Then after taking the summation of this static internal indeterminacy and static external indeterminacy, you can find out the total degree of static indeterminacy. So by using these two approaches, you can determine the static indeterminacy of rigid jointed plane. Coming to the first example, determine the degree of static indeterminacy of portal frame. So this is the portal frame. So here these are the vertical members and these are the horizontal members. The horizontal members is called the beam and the vertical members is called the column. And this is the support. So this is the portal frame. This is the rigid jointed plane frame, and here you have to find out the degree of static indeterminacy using this equation, ds is equal to 3m plus r minus 3j. So here you have to count the number of members and number of reaction components and number of joints. So here you count the number of members, how many members in this portal frame. So here you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 number of members. So M is equal to 21. Then count the number of reaction components. Here you see at fixed support, so there are 3 reaction components. Here there are 4 fixed end. At each fixed end there are 3 reaction components. So here 3, 3, 3, 3. So the total number of reaction components equal to 12. R is equal to 12. Then count the number of joints. Here first joint, second joint, third joint, fourth joint, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13, 14, 15, 16. 16 joint. J is equal to 16. Then put this value in this expression and find out the degree of static indeterminacy directly. So 3 into 21 plus 12 minus 3 into 16. So ds is equal to 75 minus 48 is equal to 27. This is the degree of static indeterminacy of this portal frame. Then find out the degree of static indeterminacy using the second approach. In this case, so you have to find out what is the degree of static external indeterminacy and you have to find out what is the degree of static internal indeterminacy. So first we will find out the degree of static external indeterminacy. So the degree of static external indeterminacy can be determined using this equation, dsc is equal to r minus 3, where r is the total number of reaction components. So here you see 3 reaction, 3, 3, 3. Total number of reactions are equal to 12 numbers. So dsc is equal to 12 minus 3 is equal to 9. So the degree of static external indeterminacy is equal to 9. Then find out the degree of static internal indeterminacy. This is the equation, dsi is equal to 3c. 3 into c is the number of chords. Here how many chords required to make the structure open configuration? Here you see, if we will cut here, then this will become the open, and if we will cut here, this become the open, and if we will cut here, this become the open, if we will cut here, this become the open, if we will cut here, this become the open, if we will cut here, this become the open. How many chords required here for the open configuration? 1, 2, 3, 4, 5, 6. So 6 chords are required. 6 chords are required to make the structure is your open configuration. There are no closed loops. All loops are open. All loops are open. See the number of chords required to make the structure open configuration is equal to 6. Then you can find out the degree of static internal indeterminacy. So this is equal to 3 into 6 is equal to 18. Then you can find out the total degree of static indeterminacy. ds is equal to dsc plus dsi. So dsc is equal to 9 and dsi is equal to 18. So 9 plus 18, that is equal to 27. The total degree of static indeterminacy is equal to 27. And here also you got in the first approach 27, and here in second approach also you got 27. Then coming to the next example, determine the degree of static indeterminacy of portal frame. This is the portal frame, here this type of structure, and you can find out the degree of static indeterminacy by using this equation. ds is equal to 3m plus or minus 3j, and here you have to find out the number of members, number of reaction components, and number of joints. And here this is the fixed support. So at each support there are 3 reaction components. So total number of reaction components are equal to 3, 3, 3, 3, 12. Total number of reaction R is equal to 12. Then count the number of members: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The number of members are equal to 14. Then count the number of joints: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of joints are equal to 12. J is equal to 12. Then put these values in this expression and find out what is the degree of static indeterminacy. So ds is equal to 3 into 14 plus 12 minus 3 into 12. So this is equal to 54 minus 36 is equal to 18. So the degree of static indeterminacy of this portal frame is equal to 18. Then find out the degree of static indeterminacy using the another approach. So here you have to find out the degree of static external indeterminacy and degree of static internal indeterminacy. The degree of static external indeterminacy can be determined by this formula. dsc is equal to r minus 3, and here the number of reaction components are equal to 12. 12 minus 3 is equal to 9. dsc is equal to 9. Then find out the degree of static internal indeterminacy. So using this formula, dsi is equal to 3 into c, where c is the number of chords required to make the structure open configuration. So here how many chords required to make the structure open configuration? So because here there are 3 closed loops. If you look out here, then this become the open. If you cut here, this become the open. If you cut here, this become the open. This one. Cut here, this is the open shape. If you cut here, this is the open. If you cut here, this is the open. So 3 chords required to make the structure open configuration. So what is the degree of static internal indeterminacy? dsi is equal to 3 into 3 is equal to 9. So the degree of static external indeterminacy is equal to 9, and the degree of static internal indeterminacy is also equal to 9. So the total degree of static indeterminacy is equal to ds is equal to dsc plus dsi is equal to 9 plus 9 is equal to 18. And here also you got in first approach the degree of static indeterminacy is equal to 18. Now all are clear how to find out the degree of static indeterminacy of rigid jointed plane frame using the 2 approaches.